Okay, today's lesson is about simplifying algebraic expressions. Yeah, I think this one's pretty challenging, so, you know, try and go back over your notes so far, see what things you're allowed to do, and then see how you can use those things to simplify. Now remember, a common strategy here when you're doing something like this is go ahead and calculate it first, right? So, type in what it says, 4 squared times 9 to the 4, all to the power of 0.5, and you get an answer. And now at least you know what could be right. As long as the thing you come up with is also equal to 324, then it would work. Let's see if I have a theory. What if it's all multiplication, right? So what if I sort of bring the 1/2 inside the bracket, right? Because we know that multiplying, I cannot do that when they're adding. But these aren't adding. These are multiplying. So I'm going to come up with a theory. I'm going to test it, right? What happens when I multiply 4 times 81? 4 times 81. I get 324. Now I know that is the same number as the answer, so I know what I did there makes sense and works, right? Another way you could do this one, what if I separated the multiplication? So it was 4 squared to the power of 1/2 multiplied by 9 to the 4 to the power of 1/2, right? So if I separate it like that, does that also work? Well, according to this equation, what I'm doing is I'm doing 16 to the power of 1/2, right? Times, I don't know what 9 to the 4 is. 65, 61. Okay, and now what I'm going to do is I'm going to take the square root of 16. Square root of 16 is 4. And the square root of 65, 61 is 81. And once again, it multiplies to 324. So I know, right, there are other ways of sort of breaking this up or simplifying it, and I can check if the answer is right. It can be harder to check if it's right when they're variables. If you really want to check if something's right, let m be a number, like 5, check it in the original, and then check it in your answer. So let's observe this, okay? So what I'm going to do is I'm going to say m is a random number, random integer between, let's say, 3 and 10. Okay, so whatever, it's 8 for me. Now what I'm going to do is I'm going to go m to the negative 1 divided by m cubed. And you can see that's the answer. Now whatever I simplify, right, has to be the same as that number. So I know how to do this. What I do is I just make some room. All I have to do for this one, m to the negative 1 divided by m cubed, is simply equal to m to the power of negative 1 minus 3, which is m to the power of negative 4. Okay? So I'm going to go back over here. I'm going to type m to the power of negative 4, and I notice that the answers are the same. Now when I press Control R in GeoGebra, it generates a new random number. And you can see that no matter what random number it picks, the two values are the same, so I know my answer is good. Right? Now again, I don't need GeoGebra to do that. I just did it here, right? I just subtracted the exponents and I know them, right? I'm just saying if you want to check your work. So if you want to check your work, make up a number for m. Usually a number like 5 is fine. Plug it into the original, and then plug it into your answer. They should give you the same answers, right? Okay? Anyway, so I'm going to assume you know how to do that. I'm not going to check these ones unless I kind of feel that what I did I feel kind of iffy about it. Here we go. We have m to the negative 3 to the 5. Well, I know when I have a power to a power, I multiply the powers. So as a final answer here, I get m to the power of negative 15, right? That's what the simplified one looks like. Here, I have y to the 2 times y to the negative 3. If I multiply these, when I multiply powers, I add the exponents, so 2 plus negative 3, and, needs an exponent there somewhere. Right, you can't say plus negative, because otherwise it does that. Okay, so I get that, which is the same thing as y to the power of negative 1, right? All I'm doing here is simply adding the exponents together, and that's it, right? That's what you get. Okay, now they're going to get a little harder, and then they're going to get a little harder, and then they're going to get a little harder. But other than that, everything else from today is the same. So it's just working on these things. I'm going to do a bunch of them. I'm going to leave a couple of them undone because I want someone from the class to do it and post it to the website. Okay, I'll give a link to that in today's announcement. Okay, again, it says express each answer with positive exponents. That means we're not allowed to leave a negative in our answer. So let's do the question first. So it's m to the power of negative 3 plus 5 plus negative 2. Or let's just say minus 2. We don't really need to. Okay? All of that, if you simplify that, you just get m to the power of 0. And we know that anything to the power of 0 is simply equal to 1. Okay? So that first one simplifies. There's no exponents left, so I don't need to worry about what it says about positive exponents. Now here, second one. I have a to the power of 3 subtract negative 1. Okay, right? And then I have b to the power of negative 4 subtract 3. Okay, so what happens here? That's a to the power of 4, and then b to the power of negative 7. Now, the question says you're only allowed to use positive exponents, so I can't leave b to the negative 7. I have to give another step and say my answer is a to the 4 over b to the 7. Because remember, b to the negative 7 mean a negative sign in an exponent means switch it with the numerator or the denominator. Right now it's in the numerator. I send it to the denominator, and then the exponent becomes positive. Let's say again, I'm a little iffy on this one. I'm not too sure I did this right. So I'm going to make up a number for a. Let's say a number between 5 and 10. I'm going to make up a number for b. Okay, again, you don't need to make random numbers. You can just pick a number like 5 and 6, let's say. Okay, now what I'm going to do is I'm going to type exp1, which is the first expression. A cubed times b to the negative 4 divided by a to the negative 1 and b cubed. Okay? You can see that the answer I'm looking for is 3 over 128. Now I'm going to try exp2, and this time I'm going to give my answer. A to the 4 over b to the 7. The answer is the same, right? I'm going to try with different random numbers. 10 and 7, the answer is the same. 7 and 5, the answer is the same. 8 and 5, the answer is the same. You get my point. No matter what numbers you pick, I think as long as pick a positive number. I wouldn't get in the habit of picking negative numbers because it's not going to work with the rational exponents very well. But pick a positive number like 2 and 3 or 4 and 5 or whatever. Check them in the original, and then check them in your answer. If they are the same number, then you know that your answer is an equivalent expression to the original. My answer has no negative exponents in it. It has no duplicate a's or b's, so I know it's finished. I've simplified it as much as possible. Okay, do another one here. 3 times 5 makes negative 15. A times a cubed makes a to the 4. B cubed times b squared makes b to the 5. This is all you can do in this question, because remember, it says with a positive exponent, it doesn't say every number has to be a positive number. You can't just change the negative 15, right? You could change a negative exponent. You don't change a negative coefficient. Okay, next one. It says x squared over y to the negative 3 to the negative 2. Okay, I'm going to remember a trick. Remember my trick. A over b to the negative 1 is simply equal to b over a. And let's put it as a 2 just so we don't mix this up. If you have a fraction to a negative exponent, both the top and the bottom can switch, and then you can make the exponent positive. So again, let's just make this really easy on ourselves. Put the y to the negative 3 on the top, the x squared on the bottom, and then all of this is to the power of 2. And now I'm going to distribute that 2, y to the negative 6 over x to the 4. And now I can't leave that y to the negative 6 on the top, so I'm going to bring it to the bottom. and I get that. Okay, remember, y to the negative 6 can go to the bottom. If it goes to the bottom, then what's left behind is not a 1, but a 0. Again, let's do a quick check of this one. So my first expression was I'm going to call it a and b. So a squared, b to the negative 3, all to the power of negative 2. My new expression is the one I'm giving you here. It's 1 over b to the 6 and times a to the 4. And you can see again, whatever two numbers I pick, I get the same value. Okay, so I know I did that right. Okay, let's, again, you can attack these ones any way you want. I'm going to start this one by distributing all the exponents inside their various, so I'm going to get, w to the 6, x to the 3. Okay, that all I'm doing there is I'm doing a power of a power by multiplying them. And then on the bottom, I have w cubed and x to the negative 2. Okay, because the negative 1 comes in the bracket. Now again, all I have to do to finish this question, subtract the exponents. So w to the power of 6 minus 3 and x to the power of 3 minus negative 2, which is equal to w cubed and x to the 5. Okay, so that's the simplified version of what you see there, w cubed and x to the 5. Okay, all right, now what we need to do, express answers in rational form with positive exponents. So that means rational form is no decimals, and positive exponents means you got to move all those negative exponents. Okay, so first of all, let's simplify this thing. I'm going to distribute the negative 1/2 to each part. Okay. Okay. Okay, so I basically put the negative 1/2 on each part. Now what happens when you do this? In the case of 16, right, the 1/2 turns it into a 4, and the negative 1/2 turns it into a 1 over 4. Okay? 1/2 changes 16, you take the square root, you get 4. But then it's a negative exponent, so it's not 4, it's 1 over 4. Now in the middle one, I get x to the negative 3. Okay? And then I get y to the negative 2. And again, all I'm doing there is multiplying 6 times negative 1/2 and 4 times negative 1/2. Now to finish this off, all that's left on the top is a 1. On the bottom is 4x cubed y squared, right? Because I take those negative exponents and put them on the bottom. Now it says I'm supposed to evaluate by putting in x equals 2 and y equals 1. So sub in x equals 2, y equals 1. And I get 1 over 4, 2 cubed times 1 squared. Oops, sorry. Okay, like that, which is 1 over 4 times, 1 over 4 times 8 times 1, which is 1 over 32. Okay, and that's my answer. Simplify, express answers in rational form with positive exponents. Okay, so again, more of the same. And then I think, yeah, I may do one of these, and I'll do one and leave one. I'll do maybe one from this row, and we'll do a couple of these ones so we get the hang of it. Okay, so this first one, 36 to the power of 3/2 m to the power of 4. Okay, so you can change this, so let's distribute sort of the exponent. 36 to the 3/2 times m to the power of, now if I do 4 times 3 over 2, it's numerator times numerator, so think of it like 4 over 1 times 3 over 2, like that. And what you get when you reduce that, 4 times 3 is 12, and then divide by 2 is 6, right? So you have m to the power of 6. Now, what the heck is 36 to the power of 3 halves, right? 36 to the power of 3 halves, to the power of 3 halves, okay, is equal to 36 to the power of 1 half, okay, and then all cubed. Now, why would I want to do this? 36 to the power of 1 half, let's try again, 36 to the power of 1. Okay, there we go. Now, 36 to the power of 1 half is just 6, right? Because remember, 1 half is a square root. So we end up here with just 6 to the power of 3, which is 216. Okay? So as a final answer here, you get 216 m to the power of 6. That is the simplified version of this. Now again, let's go through and test it. So I'm going to rename this to m, and my first expression is equal to 36 m to the 4, all to the power of 3 over 2. My second expression that I said the answer is 216 times m to the power of 6. And again, you see the two answers are identical, right? They give you the same number, so I know I did that right. Okay, this one. 8x cubed b cubed all to the power of 2 over 3. So I get 8 to the power of 2 over 3, x cubed to the power, x cubed to the power of 2 over 3 is only going to leave me with x squared, because, yikes, what is wrong with this thing today? Okay, so the 2/3 comes down with the 8. The x to the 2/3 multiplies by the 3 and just leaves you with a 2. The b also leaves you with a 2. I look at the 8. The cube root of 8 is 2, so that deals with the 3 underneath. And then the 2 on top, I'm going to square it. I get 2 squared, which is 4x squared b squared. I'm not sure why my equation editor is having so much trouble here, but 4x squared b squared. Okay, I'm just going to type it out normally without the equation editor. 4x squared b squared. Oh, I must be in like superscript or something, right? Yeah. Okay, that's the problem. Okay, it's alright. I've never had that happen before. Okay, so you end up with this. 4x squared b squared. 8 to the power of 2/3 is 4. X cubed to the power of 2/3 is just x squared, because you multiply them together and the 3's cancel. And the same thing with the b. Okay, so question C here. Okay, so I got to do 25 to the power of negative 3 over 2. Okay, so let's try this one. Oh, I see what's going on. Okay, somehow I just got to the bottom of the document. Okay. Okay, 25 to the power of negative 3 over 2, okay? And then I have a squared times, right? So times negative 3 over 2. That isn't too hard to deal with. So first of all, let's fix up the negative. So let's make it positive. So we're going to go 25. So make it 1 over 25 to the 3 halves instead. Okay? So that deals with the negative. Then we have multiplied by a to the power of negative 3. As the 2's cancel there in the multiplication. So you have 1 over 125 a cubed. Okay? 25 to the 3 over 2. Let's think it through. Get rid of the 2 on the bottom by taking the square root. That brings it down to a 5. Cube the 5 with the 3. That brings it from 5 to 125. Okay? The a to the negative 3, I make this a positive exponent and send it to the bottom. Okay, so you can see they're starting to get more complicated here. I'm gonna do D. So I'm gonna do this one. I'm gonna leave this one for you, and I'm gonna do F. I'm gonna leave those two, and then I'm gonna do I. So I'm gonna kind of do one from each row, and I'll leave the others. Okay, I want you to check on the website to see the solutions, or try them and post your own solution. That would be the best thing to do. Even if it isn't right, post it. Say this is what I tried. What did I do right? What did I not do? I'm happy to give you that feedback, right? If you just post it to the discussion area so everyone can benefit from it. A lot of people make the same mistakes, right? Okay, so here, what we need to do. The first thing I want to do here is I notice that 8 and 125 and x cubes are all perfect cubes. So what I'm going to do is I'm just going to say this is 2 over 5x all squared. Right? Do you see what I've done? I've taken the cube root part. So let's write an intermediate step here. Let's write an intermediate step. Okay, so what I'm saying here is let's copy the question out. So 8 over 125x cubed. Okay, now instead of doing it to the power of 2/3, I'm going to take the entire thing and I'm going to put it in a cube root. Right, because that's what the 1/3 means. Okay, well, I don't know what it's doing. It doesn't take too long to type it out again. Okay, so the first step I'm saying here is I'm saying, rather than deal with 2/3, let's make it a big cube root and then put the squared in there. Right, and now that I see this, actually, an even smarter way of doing this would have been to say, let's put 8 over 125x cubed in there, and then let's put the squared on the very outside, and we'll do that at the end. Now look at the cube root. Cube root the 8 becomes 2, cube root the 125 becomes 5, cube root the x becomes just x, and then all you have left is all of that squared. Okay, and what do you get there? You get 4 over 25x squared, right? That's the final answer. So that, again, really good question. Hard to do, right? But, if you know your rules, you will be able to do a question like this. I think these are, something like this is something I would expect you to do. I'm not going to give you 20 of these, but one like this for sure, right? Simplify and show me you know the rules. Okay, I'm going to leave E for you. So let me just write this down. So I'm going to leave E. I'm going to leave G and H. Especially H there is a good one. And then I'm going to leave J. And of course, if a couple of days go by and nobody posts any solutions, I can post some solutions. But I really want you to give these ones a try without just copying them, to make sure you're learning it and not just copying it down. Okay? So let's look at F. To do F, all I have to do is distribute the 12 into each of the parts. So I'm going to go x to the power of 12 times 1/3, y to the power of 12 times 1/4, and this is not too bad. 12 times 1/3 is 4, and 12 times 1/4 is 3. So that one simplifies relatively easily. Okay? I don't think this one is much different. If you can apply that same idea, you should be able to do those two. Now this I one is really, it's nasty, it looks complicated, as is this J one, so let's do the I one together, and then you can see if you can apply what you learn here and try it to J. Now again, there's many ways you can look at this one. Your job is to basically decide something that's going to make it look easier, and then do it. So I'm going to tell you what I'm going to do to make this easier right off the bat. I'm going to take the bracket, I'm going to change the exponent to a positive 1/2. Okay, so I'm going to change the exponent to a positive 1/2 instead of a negative 1/2. And to do that, I'm going to bring the bottom. Yikes, this is tricky to type. Okay, so x5y cubed. I'm going to bring the bottom to the top. Okay, and the top to the bottom. Let me just make sure I got this right. So this was the old bottom, 4x to the 5y all cubed. The top was 2x to the negative 2 squared times y. Okay, so this is my first step here. I don't like negative exponents, so I'm going to flip the fraction over and make it a positive exponent. Now what I'm thinking is, let's open up this bracket and we'll just get rid of all the brackets inside. So we still have all of this to the power of 1/2. Oops, sorry. Okay, let's open up the brackets inside. It says 4x5y all cubed. So what happens there? I get 4 cubed, x to the 15, y cubed. Okay, because everything has to multiply, by that exponent. On the bottom, I have 2 squared, okay, x to the negative 4, and then y. So I have that. Okay. Now let's go through and just clean up the numbers. So let's just do a quick copy paste. 4 cubed, I know is 4 times 4, which is 16, times another 4 is 64. 2 squared is equal to 4. So, no. Okay, so I have that. Now, 64 divided by 4, I know what that is. 64 divided by 4 is 16. Now look at the x's. 15 take away negative 4, right, is 19. 15 take away negative 4 is 19. And then I have y, 3 take away 1 is 2. Now all of that has to be put to the power of 1/2. Okay, you know how to do this. 16 to the 1/2 is 4. X to the power of 19 times 1/2, well, nothing you can really do there. You're just going to write 19 over 2. And then y to the 2 to the 1/2, it just gives you a y again. So all that big question simplifies down to that thing there. So again, this one is worth a check. So let's go back to my check machine here and try to check it. So expression 1, the question. What was the question? It was a big bracket to the power of negative 1/2. And then the big bracket was a little bracket to I called it m, to the power of negative 2, all squared, times b. Okay, then we had to divide this by 4m to the 5th, b, all cubed. Okay, so we get that number. Now my simplified expression, I said, was 4 times x to the power of 19 over 2 times y. Now, of course, y is b in my GeoGebra, x is m. Okay, and this is what expression 2 was equal to. Okay, again, you can see I'm 100% confident I've done this right, because when I pick two random numbers, the original expression is exactly equal to my expression. Okay, so I know I did that right. Now, again, it's a challenge, but I want you to try J. Okay, so that's it for today. This lesson is a really important practice type of lesson. Okay, these are tough. I'm not going to give you multiple questions that look like this. You're going to get one, right? So, it's not that you need to do them all. It's not that you should expect to get a ton of these things, but, I am expecting you to learn how to do this. So, look through my steps for solving I, look through your rules, and best of all, come up with a theory and try it. See if it works from line to line. Plug in x equals 2, y equals 3. See if your line is equal to the line that came before it. Post your stuff online, right? See if you can, where did I go wrong here? What's right? How can you help me with what we're doing?